Hello everyone. In this session I am going to give you a quick overview of the R programming language. So as an agenda for this course, we'll talk about how to get started with R, wherein I'll be talking of giving you a basic instructions on how to install R. Once it is installed, how to typically load R. So these are the major areas that come in here. Then the basics, if I have to work with a few R commands, some of the quick basics for us to understand. Then I'll talk about the basic objects of R. So R uses the names like vectors, lists, etc. So I'm going to talk about some of the basic objects, though I would not be going too much in detail into each of these, but I have to give you a very basic overview of how R typically handles all these kinds of objects. Here we would also talk about different kinds of data types, right, like integers, numeric, etc. Then one of the major data types in R, data frames. We are going to spend some time in terms of understanding what these data frames are. Then how do we really load the data, either from the typical R data itself, which is what we call as native data, native files. So how do I really load them, how do I save them, and along with that, how do I really load some other data, some other kinds of data, let's say a CSV file or an Excel file. So how do I really load them and how do I really save them? So we are going to have some basic understanding of that. There are lots and lots of functions, features that are available as a part of the base R itself, as a part of R functionalities itself. But still, in many cases, it is very much the need to write our own custom functions in R. So it may be needed that I may have to write my own function in R. So if at all I have to write such kind of stuff, we'll be talking about some kind of framework regarding that. And after that, we'll spend some time in terms of understanding the common control structures in R. So something like if, then, else. So some such kind of structures are there as a part of R. The for loop. So there are a few control structures as a part of R. So we are just going to understand what kinds of things are there. See, the intention of this session is I want to give you a basic overview of what all are there as a part of R. Now once you know these are the different things that are present, for getting a much more detailed understanding of each of these things, you can very well refer to any other kind of a literature on R as well. So this is just to give a kind of a broad overview. And finally, when I am quitting R, how do I really clean up the stuff? So these are the various aspects that are being taken care of as a part of this session. So if I have to really get started, the first thing is I need to install R. So the R base is actually applicable at this particular link, right? So the R base is available at this particular link. So let me try this link. So if I am clicking on it, this is called CRAN. CRAN stands for Comprehensive R Archive Network. So if I go to this particular location, this is the website. So I can download the R for my particular operating system, either Linux or Windows or Mac. So I go for R for Windows. All I have to do is I have to download this base. So I click on this base. So I have to download this R version on my Windows. The same logic goes if I'm using a Mac or a Linux kind of an operating system. So it's a simple process to download it, and once I download it, I can quickly run it, and it will typically install R on my system, right? So once it is installed, I have to run it. So if I have to run it, I'm going to my program files directory. I'm simply running R. So this is how a typical R screen looks like, right? There's a version, I have installed a slightly older version, right? But when you are working on it right now, you can install the latest version 3.3.1. What is there on my system is 3.2.2. Alright. So you could see it's free software, comes with absolutely no warranty. You can even redistribute it under certain condition. So if I want to see the license relating to this, I can simply type this kind of a command, right? So I'll do that. The natural language support is there, but running in English. And you could see it's a collaborative project with many contributors. So if I want to know the list of contributors, I can type this, contributors with an open bracket and a closed bracket. Citation, I can do this. For each of the packages, if I want to know how to cite it, I can simply do this. So a few more things, if I want a demo, I can use this. If I want a help, I can use this. There are a few things like this. But first thing, whenever R gets started, the first thing we observe is this greater than kind of a symbol. So the greater than symbol indicates that R is ready for input. I can give some kind of input to R, right? So if I say log or probably 2 plus 3, a simple input, I press enter. So R computes it as 5. 2 multiplied by 3, R computes it as 6. Or square root of 25, R computes it as 5. So I can just give the instructions, and based on that R does the computations. So whenever you come across this greater than symbol, it means that R is ready for input. Now let's say I want to create one variable. Variable is nothing but it's a memory placeholder. So I create some variable called X, and let's say I want X to store a few values, 1, 10, 5, 20. Let's say I want X to store these 4 values. So whenever I want to store a set of values, I'll combine those set of values with a C function. C is here concatenate. The C that I have used here, remember R is case sensitive. I'm using a small c. The C is standing for concatenation. So I want to use these 4 numbers 1, 10, 5, 20. All 4 of them I want to assign to this variable called X. So the assignment is being shown with a less than symbol with a hyphen. Less than and hyphen are together, right? So this means these 4 numbers 1, 10, 5 and 20, they are assigned to this variable called X. So if I want to see what this variable contains, I can simply type in X. So when I type in X, it is printing back what I have typically provided, 1, 10, 5, 20. So these are the 4 values that are contained as a part of X. In some cases, let's say I'm doing, right, I'm trying to do 2 plus 3 plus 5 multiplied by something, and when I press enter, this time I'm getting a plus instead of a greater than, because I haven't completed my previous statement. 5 multiplied by what? So I haven't completed my previous statement. So when my previous statement is incomplete, then I will get a plus instead of a greater than symbol. So which tells that R could not run the previous statement, so it is still expecting something from you. So one way is either provide what it might be expecting. So probably if I say 5 multiplied by 3, then it will typically perform the calculation. Or in some cases, if I don't know what it is expecting, I can simply press the escape button on the keyboard and it will come back to the greater than symbol again. The greater than symbol is what we call as R prompt. So that is the word which I am going to use from the next time onwards. So in majority of the cases I will get an R prompt, but if I don't get an R prompt, but if I get a plus symbol, it means that my previous instruction is not fully executed by R. There is something incompleteness in the previous command that I have given, so I have to better correct that command. That is what is the meaning of this. And in some cases I'll put a hash. So when I say square root of 25, and I'll put one hash here saying I can type my notes, computes the square root of 25. So here what is that I am doing? I am first executing a command, after that I have put a hash, and after that I am writing something. Now this is typically taken as a comment, kind of a notes. Anything after this hash, R does not process it. It simply gives is for our advantage that this is more of a comment rather than any kind of an instruction. So for us as a notes or for us as a documentation. So if I want any variable values to be printed as I have shown here, if I type in X, I get the values of that particular variable. So if I want to assign something, let's say I want to do 5 multiplied by 6 and I want to assign it to X. So I'll say X assigned to 5 multiplied by 6. Now when I am typing X, now I'll get whatever is the computation that is coming out of 5 multiplied with 6. So that is what is the basic operation that we are doing with R. Few things to be careful of before we really get more and more dived into the usage of R. R is more case sensitive. So if I am using a variable small x versus capital X, my outputs will be different. So depending on if I have assigned small x some values, I type capital X, I will not get any kind of a response. Here to this small x I have assigned 5 multiplied by 6. But if I type capital X here, I get error saying object capital X not found. So it is case sensitive. I have to be very careful between the small letters versus the capital letters. And keyboard up and down arrows, especially now here I have already given a few set of commands. So if I really want to go to all my previous commands one after the other, I'll use the up arrow of my keyboard. So okay, first it is showing X because that's the last used command. Then a small x, which is the command that I have used before it. Then X assigned 5 multiplied by 6. This is what is the previous command. Then again X here. Then square root of 25. Then 3, which was not a command at all. Then even X. Then this one. So all the set of commands, if I want the previous ones, I can simply keep pressing the up arrow. And once I have gone to a couple of previous ones, if I want to again come to the next ones, I can keep pressing the down arrow. So up and down arrows primarily are for the purpose of navigating to the previous command that I have typed. So I can call any of the previous command. If at all I want to make some kind of modifications to it, I can very well do it and re-execute it. And in some cases, I can type in all my commands into a separate, I say a new script file, and within this new script file, I can start typing all of them. So let's say I'll type 2 plus 3, then I'll type 2 multiplied by 3, then I'll type square root of 25, then I'll also type log 50. So these are the different kinds of things that I'm typing. So let's say I want to execute this. I go here and I do Control R, right? I select this. So if I say log 50 is what I want, I select this and I do Control R. So suddenly the log 50 is getting executed and I am getting my result. So I can write all my script here, whichever is the one I want to execute, I can just select it and I do a Control R. Control R is for typical running of the particular command. So sometimes it's better to open a new script file and in that script file write out all your lines, so that whichever is the one you want to execute later, you can very well just select it and do a Control R, that gets executed immediately. So that's one more basic thing that we have to be comfortable with. Now moving forward, now I am going to talk about some basic objects that are present in R. Just like we have many other programming languages like C, C++, Java, R differentiates between data and functions. Right? Functions are majorly targeted towards action. I can find the mean of some data. I can do the sorting of some data. Or I can compute the standard deviation of a data. So some kind of an action that is performed on a data is what a function is, and the data is just the raw information that is available. And for different kinds of data that I am having, the data types, different kinds of data types exist. And in R, the most common data types are vectors. The vector is the most basic kind of data type in R. Then we will be talking about lists, another important data type. But the most important one, probably if you ask me one single data type that helps me to do different kinds of statistical computations, statistical analysis, model building, lot of things, I say that it is the data frames. So these are the three major data types that we see in R. So getting a good hold, of course there are few more things like matrices, etc. But getting a hold of these things is definitely an important thing if you are going to do some kind of analysis in R. And in general words, any kind of data, functions, or anything else that is processed by R, the general notation for that is an object. So many a times we you keep hearing this word object when I'm taking these sessions, but object means it could be a data, it could be a function, or anything else that is typically processed by R. Now we'll spend some time in terms of understanding the vector. Vector is nothing but it's a one-dimensional collection of different data points. In our example earlier, when I said X is taking, or probably let me call it Y, y takes a sequence of values, joining them through the command C command 1, 4, 9, 16. So when I take y as these 4, so y, when I simply type y, I get a set of 4 values. And this is called as a vector. Vector is nothing but it's a one-dimensional collection of data points and they are all of a similar kind. So how do I know what is the kind? I can simply type the class of y. It is numeric. So all 4 values here are numeric. So vector, when I have to define a vector, it's a one-dimensional collection of the data points and all of them are to be of a similar kind. If at all they are of different kinds, R automatically converts them. In case I have given the different data points of different kind, R typically converts all of them to a very common kind of type. Right? So for that matter, just to make you understand, let's say Z is a variable which I am giving 1, 2, A. Let's say I am giving these 3 variables to Z. Right? So when I am typing in Z, it is typing 1 to A. But now look at the class of Z. It says character. Though it has 1 and 2 which are numbers, but A, because of A, the whole thing is typically being made as character. So this is what I am saying. If at all the different data points are of different kinds, R typically automatically converts them to a very common type, generally character kind of a type, which all of them can be typically considered as. A number can be considered as a character, but a character cannot be considered as a number. So that is where the common type becomes character. So we have already talked about the C command, right? You are entering the elements of a vector. So wherever I am putting the C can typically have the numbers, or even it can take characters, as we have seen now. Characters means strings, or it could take even the logical values also. Let's say A is the kind of variable that I am entering, where I am giving inputs like true, false, false, true. So even this could be a vector. So if I type A, I am getting true, false, false, true. And if I am typing the class of A, it is saying logical. So logical is also one more class, one more type of the data. Right? So I can have data which is numeric, I can have data which is character, I can have it which is logical. All these are vectors. Right? So the similar kind. The kinds that we are typically looking at are either logical or character or even numeric. So whenever we are using the C command, it means that you are entering the various elements of a vector. And so that the C command can typically, the vector can typically have numeric data, which we have already seen. Logical values also we have seen. Character strings also we have seen. And all the vectors. Now let's say I want to append 2 vectors, right? I have a vector Z which is containing characters. I have a vector Y which is containing numbers. Let's say I want to append both of them. Then also I can use a C function. I can say C of Y comma Z, means the vector Y and vector Z are combined. So this is where you could see 1, 4, 9, 16. This is vector Y. 1, 2, A, vector A, vector Z. But now you could see all of them, though vector Y is numeric, vector Z is character. When you have combined them, again it is combining them into a common type. So that is where you could see the class of C of y comma z is typically a character. So it is converting them into a common type. Now the other important aspect, now on these vectors there are different kinds of functions. Especially if I talk about a summary function, right? Let me do this summary for different kinds of vectors. So I'll do the summary for y, which is a numeric vector. So when I do a summary for y, which is a numeric vector, I get all these values. 1, which is the minimum value, I'll get the first quartile value, I'll get the median value, I'll get the mean value, I'll get the third quartile value and the maximum. This is what we call as the 5-point summary, right? Which is what is an important aspect in coming out with a box plot. So this is typically given using the summary function on a vector, especially if that vector is a numeric vector. But similarly do the summary function on z, which is a logical vector. It simply says it is having a length of 3 because it's having 3 values, right? No, what is this? Z is character. Sorry, it's not logical. Z is character. It's having 1, 2, A. So that is where it's saying its length is 3. The class of it is a character. So that is what the summary does not give anything beyond that. It only says what is the length of that vector. But at the same time, if I do it on a logical vector A, it says it's a logical vector. There are 2 falses in it. There are 2 trues in it. NA means it's a missing value. I'll talk about it in a short while from now. But what this is saying is again a summary. There are 2 falses in this data and there are 2 trues in A. So that's what is the summary. So the typical summary as a function, it is giving me an overall view of an object, right? So object here is a vector. It's giving me, so I can use it on vector, I can give it use it on list, anything. Summary is something which is giving me an overall view of that object. And we are seeing that the result that we are getting, it purely depends on the type of that object. And we have also seen we'll get some kind of descriptive statistics like minimum value, the maximum value, the Q1 first quartile, Q3 second, third quartile. I'll get the median value, I'll get the mean value when I am doing it for numerical data. Then the next point that I want to discuss in vectors is the indexing. Here when I am doing, let's say y, I am getting the values 1, 4, 9, 16, all 4 of them. But let's say I want to get only the second value, means I want to get only a subset of the entire vector. I don't want the full vector. I want only a few of them. Let's say one single element of that vector. That is what I am calling through indexing. Indexing is what is going to give me the subset of any kind of a data structure. It could be for a vector, it could be for a list, it could be for a data frame. In all the cases, the subsetting is typically done not with a common bracket but with a square bracket. So let's say here I want to get the second value, right? I want to get the second value of y. I'll simply say y and in the square bracket put 2, which says it will pull out the second value of y, which is 4, right? Otherwise I want to put y of 4. I want to get the fourth value of y. It comes out as 16. The same thing I can do for z as well. The second value of z, it gives me that the value is 2. So any kind of a vector, any kind of data structure, if I want to get a subset of values of that, I can very well do it using the indexing as a concept. And any kind of operation that we are doing, right, that operation is applicable across the entire vector. What I meant is, let's say y. These are the 4 numbers. Now simply when I say y plus 2, what happens is this plus 2 will occur across all these 4 values. This plus 2 will be performed across all the 4 values. So it becomes 1 plus 2, 4 plus 2, 9 plus 2, 16 plus 2. So this is what I meant by this computation is applicable across all the vectors. So R automatically applies any kind of an operator across the entire vector. If I say y squared, y to the power of 2, I'm going to get directly the squares of all the elements of the vector. Now another interesting thing, let's say I want to add 2 vectors of 2 different lengths, right? Y is a vector with 4 values, and let's say I'll create another vector b with just 2 values, 1, 2. Now y is a vector with 4 values, b is a vector with 2 values. Now let's say I want to do y plus b, right? Now I'm getting the answer 2, 6, 10 and 18. What has happened? Let me just explain it here. Y is a vector containing 1, 4, 9 and 16. B is a vector that is having 1, 2. Now what typically happens is when I'm adding these two, this small vector keeps repeating until the length matches the large vector. And after that, the addition typically happens. So this is what is the functionality in R. If I am adding 2 vectors of 2 different lengths, the smaller vector typically recycles until its length matches the larger vector. So if at all so here R does not give any kind of an error. It simply recycles the smaller set, and based on that it does the computations with the larger set. So we have to be very careful. We have to better check the lengths of the vectors before doing any kind of calculations, because we will not get any kind of errors in the process, right? So some of the interesting things, but once you start working with the data, it becomes more and more handy. You will be getting used to all these things. But yeah, some of the basic things before we really get into the process of understanding the data, creating some kind of analysis out of the data and all those kind of stuff. And looking at a few more interesting facts about the vector. Here there is one more data type called matrices, right? When I say matrix, the same, I can put matrix of y. I'll put y as a matrix, right? Earlier y is a simple vector. Now if I have to talk about a matrix, I'll set y as a matrix saying n row, number of rows 2, right? N row of 2 or n row equal to 2, which means I am setting number of rows equal to 2, and automatically it becomes columns. The columns are taken based on the total number of observations and the number of rows. So based on this, the same y is converted into a form of matrix. Now when I am talking about a simple multiplication, let's say the same matrix I want to multiply 2 times. I'll recall the previous function, but if I put just a star and do the same multiplication. This is a plain multiplication. In this plain multiplication, so it's a position wise multiplication. It's just like a squaring. So 1 will be multiplied by 1, 4 will be multiplied by 4, 9 will be multiplied by 9, and 16 will be multiplied by 16. That is where I am getting this matrix. Whereas if I have to really perform a matrix multiplication, instead of putting a simple star here on a matrix, I'll put percentage star percentage. This is what we call as a matrix multiplication. You know the matrix multiplication, right? So if I am having A, B, C, D as a matrix, I have to do a matrix multiplication with A, B, C, D. The first row of this will be multiplied with the first column of this. So it becomes A squared plus BC. Then the row would be multiplied by this column, AB plus BD. Similarly, this row, each row would be multiplied with each column. That is what we call as a matrix multiplication. So here it is AC plus CD, and here it is BC plus D square. So this is a new matrix. So this is what is coming out here. The matrix multiplication is getting performed, and that is the number that is shown up here. So in some cases we have to perform matrix multiplication, in which case I'll use a percentage star percentage. And if I have to perform a simple multiplication, item to item, vector to vector kind of multiplications, then I can very well use a simple star. So the matrix mathematics, right, though I am not going to get more and more deeper, because general applications I don't use too much of matrices, but yes, there are some specific applications. So when I talk about any specific application which uses matrices, especially something like portfolio management in case of finance, where the use of matrices is much higher. So wherever such kind of applications come up, I'll try to cover the matrices, but in more general kind of scenarios, we go with vectors itself, but just giving you how to treat a matrix. So if I have to do a matrix multiplication, I'll typically go with percentage star percentage rather than a simple star. This we have already talked of. R automatically assigns a data type to all the elements in a vector. Even if different vectors of different types are being concatenated, it will go with the most general or most common kind of a format. And if I want to convert something, right, let's say right now I have y is 1496. I am taking a class of y. Right now it is numeric, right? Let's say now I want to convert this y into character, right? So let me call C, where I am converting the y into a character. Then I can say as dot character of y, and that I am assigning it to C. So if I look at the class of C now, it is character. So as dot numeric, as dot character, as dot integer, as dot matrix, as dot logical. So depending on what I want to convert, I can use that corresponding as dot function to convert from the current existing data type to a new data type. That is what we are calling as coercion. And another function, str. str is nothing but the structure. If I want to know the structure of that particular vector, I can take the str. So if I talk about str of A, it says it's logical, it contains 4 values, true, false, false, true. If I talk about str of Z, it says it's a character with 3 values, 1, 2, a. If I am talking about str of y, it says it's numeric. It has 4 values, 1, 4, 9, 16. So str is a kind of a function that gives me a detailed information about the object. And in some cases, right, so right now when we had a vector, we simply said we are adding things by using a C command. But in some cases, I can even use colon operator, especially if I want a continuous sequence and that too an integer sequence. So let's say 1 to 10. So I'll simply type 1 colon 10 instead of saying a C function with 1, 2, 3, up to 10. Instead of saying that, I'll simply put 1 to 10. So these are the values 1, 2, 3, 4 up to 10. Similarly, I can put it in the reverse order as well. 10 colon 1. I'll get it from 10 to 1. So it's an auto increment by 1 or an auto decrement by 1. I can use this colon operator. Even this can be used for subsetting also. Right now y is containing 1, 4, 9, 16. But let's say I want only the second to fourth values of y, not all 4. So one way is I'll put y. I could have put C and put 2, 3, 4, which will give me the second, third and fourth values of y, which is 4, 9, 16. Or I could do y 2 colon 4. Even this will do the same job because it's a sequence. So it will take the values 2, 3, 4. So I'll get 4, 9, 16. And there's also one more way of getting the second, third, fourth. So this is where I'll use the negative operator. Right? I'll talk about it. Yeah. The negative index. Negative index is something that I want to exclude. Out of this 1, 2, 3, 4 values, I want to exclude the first one. See, if I want second, third, fourth values, it's as good as saying I want to exclude the first value. So this is where I can say y, and again with a square bracket I put -1, which means I don't want the first value. I want only the second, third and fourth values. In that case also I'll still get 4, 9, 16. So there are different ways of getting a subset of observations. Either I can use a simple C function to get those particular values that I want, or if those values are in a sequence, I can simply get them using a colon. And if there are only a couple of values that I need to ignore, that I don't want to get, I can use the negative index to omit those particular values. And in some cases, the sequencing, one way of sequencing is 1 colon 10 kind of stuff. In another ways, we have a function called SEQ. Now, SEQ is a sequence. First of all, if I want some kind of a help on any function, what does SEQ do? All I can do is, I put a question mark and just type in the name of the function. I'll get a detailed help about that function. So I need to know the name of the function, but how to use it and all those things I'm going to get quite comfortably. If I say question mark SEQ, it's a kind of help that I'm going to get, right? SEQ, this is the usage. SEQ, from something, from equal to some number, to equal to some number, by equal to some number, right? So if I want something like that, I can give an input. Let me try now. I'll say SEQ from equal to 10 to equal to 100 by equal to 5. So it means it will generate a sequence from 10 to 100 doing an increment by 5. So I'll get 10, 15, 20, 25, 30. So SEQ is for non-unitary increments or decrements. So just by looking at here, I got a help. So this is how I need to give the SEQ function, right? So I can give, so it tells me what are all the things from the starting and the maximal end of the values of the sequence by the number increment of the sequence. Length dot out, desired length of the sequence. Sometimes I can talk about the desired length of the sequence. I want 10 values altogether, right? So probably let me say the other way of using the sequence, from equal to 10 to equal to 100. I'll say length dot out. I want 10 values. So from 10 to 100 generate 10 values. Then it says 10, 20, 30, 40 because the total length is 10. So I can give the same sequence function with different kinds of inputs and get the results like this. So by using the help we can get all these kinds of comfort level. Now again going back a few more. Then another function that we use commonly in case of vectors is rep. Rep is replicate or repeat. So if you see, if I am saying rep 1, 10 means I want to repeat the number 1 10 times. So it is going to give me 1, 1, 1, 1, 1. If I say rep 1, 2, 3 10 times. So it says 1, 2, 3, 1, 2, 3, 1, 2, 3 10 times it generates. The same thing if I say rep 1, 2, 3 each equal to 10. So first 1 will be shown 10 times, then 2 will be shown 10 times, 3 will be shown 10 times. Now again if I have to see what are the different kinds of variations that are associated with rep, which is a repeat kind of stuff, I can do a question mark and a rep. So rep replicates the values in x. Whatever the x I am giving, it is replicating that. Right? So I can say rep x. So length dot out. N number of times, whatever is the number of times I want something to be repeated, I can give that as a rep input. So this is where I can use the help, and based on that I can write the function accordingly. Initially that might be a slightly intimidating kind of stuff, but once you start getting used to the question mark way of asking the help, it becomes more and more easier to work with various functions of R, because it's literally difficult to remember all the functions of R, all the different variants in which I can give the inputs to R. So more or less, even for an experienced programmer, relying on what are the various arguments that go into the formula is something that we have to keep looking at different points in time. So understanding the help function, using it more judiciously, is very much essential in the overall working with R. So any kind of a result, if at all I am performing some kind of vector operation in R, we have to understand that the result also is a vector only. And R is a very, very powerful tool. It is highly optimized for various vector related calculations, various matrix related calculations. So this is where I could see R as a very, very good low cost alternative to the mathematical modeling tools like MATLAB. So even R could be a very good alternative to SAS, SPSS for its statistical computing aspects. R could be a very powerful alternative to MATLAB for its mathematical modelings. And just to look at one more aspect, which is the help function. We have just now talked about the question mark. I'll use that question mark only when I know the name of a command. So we said question mark rep. We said question mark SEQ because we know that these are the names of the functions to generate sequence, to generate replication, etc. So if I want to know more about it, like what is the title of it, what is the description, what is this function or what is this command going to do, what are the different ways in which I can give the input into it, what is the description of each of the input. That is what we have seen here, right? If we look at, so initially there is a description saying what does this rep do, then we have a usage section saying what are the different ways in which I can give the input, then there is a detailed explanation of the inputs which are otherwise called as arguments. So some kind of details regarding the entire function. Value is how the output is going to come, what is that is present as a part of the output, some notes regarding this. So what is the kind of reference based on which this particular function has been created, and some kind of examples which we can directly copy and paste them into R to really observe what is the kind of behavior of this particular command. All these things, initially it may look quite intimidating, but the more and more we start using it, the more comfort level we get, because there is a lot of ready-made reference to understand the functions out here. In case, okay, this is when I know a particular command, but let's say I don't know a particular command, but I want to see, I want to understand a specific concept. Let's say I want to know something about a histogram, right? I don't know what is the command for a histogram. So in that case, instead of typing one single question mark, I'll put double question mark. So it will search for where all is histogram present, right? Whatever the kind of search about that particular topic called histogram, it will try to search and it will give us some kind of pointers of what can be understood regarding a histogram. Looks like my internet connection is slightly lost, right? Let me just type it again. Okay, so different kinds of references for histogram, right? I have a lot of packages installed in my system, so that's why there are so many references for this histogram. But probably if you have installed R very recently, you will not get so many references for histogram. But whatever are they, in what context histogram has been used, what are the different ways of using the histogram. So it's a kind of a complete help, just like a Google help. I type the word histogram in Google, I'll get a list of searches where histogram is matched. The same thing happens here. Whatever the various packages, whatever the various functions, whatever the various data that contain histogram in the R repository that is installed on your system, all those references are pulled out and displayed to you here. You can go in detail into each one of them and start exploring them, right? So that is one other way of getting the help, especially when you don't know the name of a command, but you want some kind of a conceptual understanding of a particular part. Then the other kind of help that you can look at is the task views. Let me just go to this link. So R has typically organized the various packages into a better grouping stuff. If you talk about distribution or econometrics, so all those packages that are helping us to do econometrics related works, so they are all grouped together. Now you could see, so there are some packages which are helping me to do a linear regression. So for microeconometrics, there are a few packages. For instrumental variables, there are a few packages. For panel data models, I have a few packages. Time series data, I have a few packages. So a lot of things, especially if I want to go more and more deeper into econometrics. Similarly, if I want to go into clinical trials, this is what it is. If I want to get into clusters, for hierarchical clustering, I have different kinds of models. For partitioning clustering, I have different kinds of packages. So you could see there are different kinds of packages, and each package, so there are almost 8,500 odd packages that are there, and they are all categorized into different subjects. Now, if I want to know about finance, there are so many packages. Again, there are few standard regression models, time series models, finance specific packages, risk management specific packages. So these are the different kinds of packages that I can refer to if I want to get into finance. Similarly, if I want multivariate analysis, you could see different kinds of subjects which you can very well enter into. So for time series, again, these are the different kinds of packages that are available. So the CRAN view, the task views also give you some kind of help on different kinds of packages that are available. Now, Wignet. Wignet for a package is like a help file for that particular package, which talks about how to use that particular package. Right? If I am installing some package, so it talks about how do you use that package, what are the various functions that are there as a part of that package, what is the notes regarding that particular package. So because package is developed by an external party, a detailed documentation relating to the package is present as a part of the Wignet. Now here itself, if I want to open one, so when I talk about econometrics, these are all the packages, right? Let me take one single package here, or let me take, okay, the car is a package. So let me click on this package. So you will get detailed companion to applied regression. This is the name of, this is the description of this package, and you could see the Wignet using car functions inside user functions. So this is a kind of a detailed explanation of how to use the various functions and all the theoretical conceptual aspect, and again with a set of examples on how to use the various features of this particular package. And there will be a reference manual to each package which will detail out all the functions that are used in this package, any data set, so all the objects. It's a kind of different objects that it explains in detail. So here you could see, if you click on this, it's a detailed documentation. So the package car, right, a few things, who are the authors of this particular package, who is maintaining it, so all these things, right, the different aspects of this particular package, all these are typically shown, and after that each element of the package is explained in detail. That is what is going as a part of the reference manual. This also exists for almost every package. And the other way of getting the help is, you can click on this link. It's an official R help mailing list. You can post your queries, you can look at the others' queries and the responses to the queries. So it's a kind of a great help associated with R, right? So there are different ways of getting the help. So it's all that is needed is getting a basic understanding of the process, but once you get into it, there's a lot of help, there are a lot of things where you can get through quite comfortably. Then the other area which is of interest for us when we are looking at R, so that is now we have discussed about vectors, some basic understanding. We also have got how to use the help file in R. Then I am going to talk about interesting things like infinities, undefined numbers, right? So let me take in a few scenarios. Let's say I want to do 1 divided by 0. So the output that comes out as INF. INF is infinite. Similarly, I put minus 1 divided by 0. I'll get minus infinity. So the infinity and minus infinity are handled in R through this process. But if I put 0 divided by 0, this is what comes out as not a number. NaN is nothing but it's a not a number. So which is what we call as undefined number. So especially if some calculation goes undefined mathematically, it gives me the output as NaN. So we have to understand the difference between infinity and NaN. Similarly, we also need to understand what are missing values. So missing values, generally R denotes them using Na. Especially if I am getting my data, let's say from an Excel sheet into R, and in Excel sheet there are some blanks, right? Some rows are blanks or some cells are blank. But when I get those cells into R will directly show them as Na. Na is a kind of understanding by R saying that it is a missing value. Right, so let me just let me create a small vector for you. Right, let me create a vector by the name D, wherein I am giving a series of values 1, 5, 10 and Na. So Na is, the fourth one is a missing value here. So D is taking a series of values 1, 5, 10 and Na. So if I want to see what is displayed in D, I am just putting D, I am getting 1, 5, 10, Na. Na is a missing value. Now, if I want to do some kind of functions on this missing value, let's say I want to do sum of D. I want to perform the sum with the D. I'll get my answer as Na, because any math that I am performing on the value of Na, I'll get the result as Na only. So whether it is sum or average or median or any kind of mathematics calculation that I am performing on Na, my result is going to be Na only. So when we are doing some kind of functions, this kind of setting we do in while writing the function na.rm equal to true. So in that case, now the same sum function for D, if I say na.rm equal to true, what it does is it first removes all the NAs, right? RM is remove, na.rm, so remove all the NAs, and after that it does the summation of D. So now I get my answer as 16 because it has added 1, 5 and 10. So in some functions, this kind of setting is there where Na is removed. So there will be in the help you can see if this particular function is going to handle the Na values. So if it is going to handle the Na values, we can set that na.rm equal to true. In some cases, we also have another option saying na.omit, right? So D, if I look at it, this is what is the D. Now I can set E, another variable, where I set na.omit of D, means omit all kinds of NAs and create a new data set. So if I look at what is there in E, E is containing only 1, 5, 10 because Na got omitted. So this is one more way of omitting, one more way of removing the NAs. I can simply either I can simply first omit, or I can use na.omit where all NAs will go off, and after that I can do the calculations. Or there is one more way where I can check. Okay, if I say is.na, it's simply for checking is every value Na or not. So this is one more way I can remove the NAs. So I'll set first is.na of D. So is.na is nothing but it will check whether each occurrence of the vector is Na or not. So the first one is false, means it's not Na. Even the second one is false, the third one is false, but the fourth one is true. Because the fourth one is Na, it is giving me that the fourth one is true. Then I can simply check the opposite of it, not. So how do I put that not? I'll again repeat the same with a exclamatory mark before it, which is saying not. Not of is NA of D will give me exactly the opposite. True, 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 false. Now I can get the subset of D where only true is there. So what can I do? This is the subset, right? This is the subset of D that I want to get. This is the subset of D that I want to get. So I'll just get only 1, 5, 10. Now I can very well perform the sum on the top of it. So when I'm doing the sum on the top of it, I'll still get my 16. This is one more way I can remove the NAs. So where we are first checking the NAs, which of them are NAs, and I'm taking only that subset from the original data where the values are not equal to NAs. So there are different ways of solving one particular problem in R. So whichever is the one I'm more and more comfortable, I can typically use that for solving my problem. So that's how we have to understand the missing values and the interesting values like infinity and not a number in R. Alright. Now moving on to the next aspect, trying to understand the lists. List is another data type just like vectors. So it's a collection of objects of any type. So we said vector is of the same type, whereas list is collection of any type and any size. So basically if I want to combine two vectors, right, if one vector is numeric and the other vector is character, I can combine both of them into a list. So just to see how that works, so here I have y, which is a numeric vector, then I have z, which is characters. I can create, let's say, L1, which is I'm calling as a list. I can create it as a list of y comma z. So if I look at L1 now, it comes out as a list. You look at the class of L1. It says it's a list. And it's also when you are trying to display what is there in L1, it says 1, the first element of that particular list is 1, 2, 3, 4, which is what is a numeric vector. The second part is a character based vector. So that's how the vectors of different types can be combined into a list. And you could also see that the lists are indexed using double brackets, double squared brackets, not the single bracket. Right? If I want the first one, let's say from this list L1, if I want only the second element of this list, if I put just a square bracket and say 2, I will be getting out of that L1, I'm getting 1, 2 and 8, right? But if I really want the elements out of that, I'll put L1 double bracket 2. So this extra thing is going to crop up. Whereas when I use a double bracket, I'm accessing it correctly. I'll get 1, 2 and 8. Now within that, if I want the second element of the second vector, now I can access it only through a square bracket itself. This will give me a value of 2. So list is typically a kind of a collection of objects of any type. Different vectors of different types can be combined into a list, and if I want to access the individual elements, I'll be going with double brackets, not a single bracket. And here with respect to lists, we have one advantage. I'll talk about one function called lapply. Lapply is nothing but list apply. So any kind of object, let's say here we have two objects, right? Here we have two objects y and z, or probably let me create another list, right? List 2. I'll call it, I'll combine y comma z comma a comma b. Let's say all these are 4 elements of the list. So now if I type in L2, so it is coming out that this is the first element of the list with 4 elements in it. Then this is the second object of the list containing 3 elements which are characters. Third element of the list which is a logical, and the fourth is again a list with just 2 values. Now let's say I want to execute summary for each of these 4 in single shot. This is where I'll say lapply. Whatever are the lists, the objects that I am looking at, so I'll put L2. So when I say L2, it is applicable to each of the object of L2 separately. And any function, let's say I want to do a mean, right? I want to do the mean for all these 4. So in the mean, x of I argument is not numeric or logical. Okay, so now you see here for all 4 of them, for the first one it is computed as 7.5. In the second case it is giving NA because they are all characters. So this is what is the kind of a warning message also it has given. They are all non-numeric or logical, that's the reason it has returned NA. In case of third, true is treated as 1, false is treated as 0, so the mean of that is computed as 0.5, and the same logic goes for the last one. So for each of the lists separately, if I want to compute some kind of a function, I can very well use this lapply kind of a feature. The main advantage why people use list is, now you have seen it, just with the name L2, I am able to access all 4 of them, X, Y, Z, A, B. All 4 of them could got accessed by just using L2. So that's the major advantage. Keeps all the data in one place, even if whatever their types are, even if their sizes are different. We have seen some of them are of 4 values, some of them have a size of 3, some of them have a size of 2, but whatever is their type, size, all of them are binded together. And at the same time I am able to apply different kinds of operations to each individual element separately. Those constitute as some of the important advantages of going with lists. And now these are the different lists and the different elements of the list. Now what I can very well do is I can give a name to each of the elements of the list. Now right now if I say names of L2, so names is like giving a kind of a heading stuff. Right now there are no names, that's the reason it is showing null. But at the same time, if I want to assign some names to it, right, so let me put A. The first one I'll call it A. The second one I'll call it B. Let's say the third one I'll call it as capital C and D. Okay, now let's try accessing names of L2. These are the names. The advantage of this is, let's say if I want to access the third, right? If I want to access the third object of that list, so one way is I could have accessed it as L2 double bracket 3. So it has given me that L2 double bracket 3 is this one. The same way I could access it as L2 dollar, the name of it, CCC. Even there I'll get the same. So dollar is a kind of an operator which helps me to access the list through its name. So I'm indexing it either I can get the subset of it using its name rather than an index. So rather than saying L2 double bracket 3, I could say L2 dollar CCC because I have given the name of the third one as CCC. That's one more easier way to retrieve the subset of that particular list as well. Then moving on to one of the most important set of skills in R, the data frame. Basically, when you are working with data that are present in the spreadsheets, tables, when you are getting them into R, they are the data frames itself. So if you look at, in short, they are most of the data sets in R are held as data frame. So they provide the most important data for any kind of statistical analysis, model building processes. So this makes data frames one of the most important skills in R to master. So basically it's a rectangular object. There are some number of rows, some number of columns of different data types which are called as variables, and rows which contain values corresponding to those variables, which we are calling them as observations. So in short, a table with headings in the top row followed by data beneath that, kind of a flat table, kind of a structure, that is what we are calling as a data frame. Small difference compared to the list. It should contain vectors of the same length, whereas a list can contain any length. Data frame consists of vectors of the same length, but of course they can be of different types, right? Now here we could see at least the first one and the third one are of the same length, so which are nothing but Y and A. So what I can do is I'll create a variable called df1 and I'll say data.frame Y, A, because they are of two similar lengths, but data types are different, but I can combine them into a data frame df1. So when I do it as df1, I am getting this as a table. Y is 1, 4, 9, 16, A is true, false, false, true. So the data frame can be created directly using data.frame kind of a command. Combine the vectors of equal lengths. And if I want to access a data frame, let's say I want this value to be displayed, then I can access it as df1. The index is I want the third row, second column. So which is giving me a value false. Let's say I want the entire third row. right? I'll say df1. I want the third row, but all columns. If I want all columns, I'll leave the columns part as blank. So it gives me the third row, 9 and false. Similarly, if I want second column, all rows. So I'll say all rows. So first rows is kept blank. The column is 2. So true, false, false, true. So I can access or I can do an indexing on the data frame using the row column combination. If the row is left empty, all rows will be pulled. If the column is kept empty, all the columns will be pulled. And let's say here one more, let me create one more variable, which is a character variable. Okay, okay, let me create y again with four characters instead of 3. So let me create it as a comma b comma c comma d, right? Now df2, I'll combine it with the data frame. So I'll take data dot frame y comma a comma b, y comma a comma. Okay, now y is made as a character. Okay, y comma a. This is what I am calling as df2. Now you look at df2. So you are getting the values a, b, c, d, true, false, false, true. And look at the class of df2, data frame. Look at the structure of df2, where you will get for individual elements. Y, we have given it as character, but the data frame has converted it as a factor. What does that mean? When it has converted it, so character data, when you are typing in case of a data frame, by default it gets converted into nominal factors. Means internally the values a, b, c, d, whatever we have entered, they are assigned some integers. So this is what is the nominal factor. A is assigned a value 1, B is assigned a value 2, C a value 3, D a value 4. So internally they are stored as a vector of integers and the label is A, B, C, D. This is what we call as nominal factors. Very, very interesting part as a part of the statistical analysis, because in statistical analysis we are required to quantify even the categorical variables, and from that perspective it becomes very essential if the if R is converting all these character data into numeric quantifications as such. So converting them into factors is very, very an important step when we are doing data analysis, statistical analysis, model buildings kind of stuff. And I can very well access all those levels. You could see here it has 4 levels A, B, C, D, which are given 1, 2, 3, 4. I can simply access them using the levels function also. Levels df2 $y. So just like the way in lists, I can access the specific column by using the dollar function. So here I will get the levels as A, B, C, D. There are 4 levels. So A is assigned a value of 1, B is assigned a value 2, C a 3 and a D a 4. And if I don't want them to be converted into factors by default, then I need to give one additional argument while using the data frame. So probably the same thing if I bring it data frame y comma a, right? then I can use this strings as factors equal to false. Strings as factors equal to false. Then look at the DF2. I'll get them as A, B, C, D. But now look at the structure of DF2. This time the structure is, it's a character. It's not a factor. So if I don't want any specific characters to be automatically converted into factors while we are taking it into a data frame, it's better that I set string as factors equal to false. So it is preventing the conversion of the characters to factors. This we have already discussed. The indices, I can leave them as blank, which selects all of that dimension. If I leave the row as blank, it will select all the rows. If I leave column as the blank, it will select all the columns. And even just like the way we have used negative indices from vectors, we can use negative indices for so let's say here I want only the second row, second column of this data frame. I want the second column. I can very well put it as a negative, saying -1, so saying that I don't want the first one. So I can say DF2, let's say I don't want the third row, so I'll put -3, and I don't want the first column at all, so I'll put -1. So which in a way is pulling out the second column only, but within that it is not giving me the third row value, so it is giving me only true, false and true. So I can access through the negative indices if I want to access some parts of the data frame. And when I'm looking at in each of these cases, when I'm pulling out these values, if it is returning a single column or a single row, then it would return it as a vector, right? Indexing a column, indexing on a column, the whole column, so I'll get the output as a vector. But if I am choosing multiple columns, I'll get a data frame. So the indexing, depending on what it is returning, if it is returning just a one single column or one single row, it will be treated as one single column. Especially if it is returning one single column, it will be returned as a vector. If my indexing is returning multiple columns, then it will be coming out as a new data frame itself. And the same way we have obtained the subsets using the names. The same logic can be for the lists. The same logic can be used even to get access to a specific columns using the dollars, which is their name. I'll put a dollar followed by the column name. I can access that particular column. So here I can say DF2 $A. I'll get the entire column which is having the title as A. So all these are the interesting aspects of data frames. As we move further, we have to do so many calculations on the data frames. Majority of the analytics part of work goes with the usage of the data frames itself. So getting comfort with the various kinds of functions associated with the data frame brings the expertise in the usage of R. Then, so this is just a brief introduction. Wherever again, as a part of our later sessions, I would be typically covering different kinds of functions that you can literally operate on the data frames. Then moving to the next aspect, how do I load and save the data? though this is what I'm going to take up sometime later in depth, but here just as a quick understanding. So there are a few R objects itself which are called as the native or the binary objects. So the kind of format in which R related objects are stored is .rdata. .rdata is an R object. So if I use the save function, it writes the binary object to the disk. So the simple thing is, either from here I can go and do a save the workspace, or probably if I want to save a specific object, right, I'll say save. Let's say I want to save the df2, the entire data frame. I want to save this df2. I should specify save df2 and whatever is the file name. So this time it will save as rdata. So I'll call it as test1.rdata. Okay, that particular file needs to be there. So what I'll do, I'll just say simply save df2. Okay, the file has to be specified. Okay, I'll go with the first one itself. File equal to test1.rdata. Yeah, this is the format. Save. I want to save this df2. File equal to test1.rdata. So the data frame is saved into a R data file. Now, where did it get stored? To understand where it has got stored, it is getting stored in the working directory. So I can get the working directory. So here, this is my working directory, C users Pradnya documents. So I'll go to that location. So I could see here test1 is an R workspace that I have saved. And if required, I can very well load that. So I'll say load from that same, I'll say test1. Test1.rdata. Okay, I have to give it like this. The load test1.rdata. I can give it with this double quotes, which will load that file which we have typically saved. So either I can save it with just the file name, in which case it saves in the default directory, or let's say if I want to save it, okay, save df2, or let's say I want to save two things. I want to save df2 as well as L2. Then I'll say list, right? When I want to save, so I think I have written that, I can save a list, a few things together by using list equal to and C function. So I'll say save list equal to C of, in this case I'll give save df2 as well as L2. So one thing I'll say save df2, save L2, both of them, and the file I'm talking of is test2.rdata. But I can also specify the location as well. This will save to the default. Let's say I want to save it in the D drive. I'll say I'll give the full path. right? D, and I'll say test2 dot R data. Now, if you look at your D directory, I should be able to see this test2 dot R data there. And within that, you'll have a data frame, which is df2, as well as, so you see test2 is present here. So you'll find a data frame as well as list in that. I can load the thing again with the same mechanism. So but here when we are loading, remember the objects, see I have saved some objects with some name Y, some name A, some name Z, etc. Right? When in our list as well as in our data frame, we internally have used the objects with names Y, A, Z, etc. But what happens is, after that, let's say I have given some other value to Y, right? Let me tell you now. Let's say I have given Y as 3. Now, so when I type in Y now, I'll get it as 3. Right? Or probably now I have given a different name L2. L2 I have given a different name 1, 2, 3. When I type in L2, I am getting 1, 2, 3. Now I'll load my data frame. So I'll say load D colon test2 dot R data. Right? Now let me type L2. When I type L2, now I am getting something else. A, B, because once it has loaded, the L2 which we have used as a variable earlier for that save, that was nothing but it was a list. So after that, when you have used the same variable again, the moment you load it, that variable name will be loaded and it will override the existing one. There is no warning also that is given that there is another object with the same name. This is where we have to be careful when we are loading things. It might very well be possible that the objects which have the same name, the newer one will be replaced with the loaded one. That is one place where we have to be very, very careful of. So I can save the file name just with the, I can save the file just with the file name as I have done in the first case, wherein they will get saved to the working directory, or I can give the full path where I want to save it. So it all depends. So I have shown both the ways of how to save, one to the working directory and one to the overall stuff. And if I want to get the working directory, I can use the getwd path, getwd, that will tell me what is my working directory. If I want to set the working directory to a different location, I can set it as setwd and give a path to it. So all otherwise, if I want to save the entire workspace, I can go here and I can even click save workspace. Even that will save my entire workspace, which can be loaded later. Now, if I want to know what all files are there, I'll say list.files. So these are all the files that are there in my working directory. Right? Different kinds of files, but because my working directory is my documents. So these are all the different kinds of files that are there in my working directory. So which will give me the list of files. And now if I want to remove a specific file, I can use file.remove. I'll say file.remove and I'll put it as test1.rdata. So it says yes, it got removed. Now there is no more test1.rdata in my files list. So simple way to test it out. Now earlier there were 1456 files. Now that I have removed one, they have become 1455 files only here. So these are some of the basic aspects with respect to loading and saving data, especially the binary or native R files. Similarly, I can do this loading and saving data from the Excel files or CSV files also. The only difference now is, instead of save, we'll use the command write.csv, the object name as well as the file name. So let's say write.csv, the same df2, data frame 2, I want to save it to csv1.csv, right? So because I did not give the full path, it will save to my working directory. So I can go and check in my working directory, which is my documents folder. I could clearly see that csv1.csv got saved out here. So this is a simple way I can write to a CSV file. Again, instead of df2, if I have multiple documents and multiple objects to be shared, I can use list equal to and use a C function as well. So this process is still the same. Of course, as we keep practicing, we'll talk about these things more and more. So R automatically includes a header row and it gives a variable name to that header row. I can do a read.csv function to typically read a CSV file into R, and I can very well assign it to some particular variable using X and an assignment operator. And a few more things here, right? Again, when we are using it in the context, they would be more and more beneficial. There is an operator which is double equal to operator, especially if I want to compare whether the two objects are exactly the same. But there is a possibility. Okay, let me just talk about something. Let me take the instance of y equal to 2 and z equal to square root of y, right? So z is coming out as 1.414214. Now I want to compare if y is equal to z square. So z is any of the square root of 2. So I want to compare, is y equal to z square. It gives me false because there is some rounding error here. Equal to is for comparing two objects. So I am comparing whether y is the same as z square. Z is nothing but square root of 2. So I am saying square root of 2 whole squared, it should be equal to 2 itself. So I am trying to compare y is equal to z square. But my result is coming out false, saying no, they are not. The reason is, just try checking y minus z square. It is not 0, it is minus 4.44 into 10 to the power of minus 16, a very, very minute number. This is coming out because of rounding error. Rounding the square root value and after that again doing the square of it is bringing that small difference. Now, if I have to ignore these small differences during comparison, this is where I am talking of another function called all.equal. So if I say all.equal x comma z square, sorry, y comma z square. Now this time I'll get the answer as true because the small rounding errors are typically omitted. So some of the things that as you keep working with, which you might be more and more comfortable with, and it can handle the various fixed file formats, databases, binary files. You can import the data, you can simply Google out, and even when we are coming across in various other sessions, we'll typically talk about them. But you can very well load the data from Excel, MATLAB, SAS, SPSS and all kinds of formats. Then the next topic which I am going to take up here is writing a custom function. There are so many functions that are pre-built in R, but still what happens is, for some kind of activities, let's say I want to repeat a specific activity on multiple data sets. In that case, it is advisable that I write my own custom function. So a set of commands I can write once and I can reuse them with multiple data sets. And here a custom function is nothing but it's a kind of it's another object, and it is treated just like the data. I can inspect it, I can delete it, I can list it exactly the same way I handle the data. Let's say we'll create one single function. Let's say I'm creating a function for coefficient of variance, CV, right? So this, as a definition, it is nothing but it's the standard deviation of a value, a standard deviation of a data divided by the mean of the data multiplied by 100. That is what I am calling as the coefficient of variance. So for that I'll create one function saying function of x, and I'll put braces. This is how I define the function. So x is the variables that are going into that function. Now here I am getting a plus because the earlier statement is not fully completed. Now what is that I have to do as a part of the function? First I have to compute the standard deviation of x, then divide it by the mean of x, and then multiply it with 100. And this is what is my function. So I'll close the bracket. So when I want to look at CV, this is where I can inspect my function, SD of x by mean of x into 100, right? Now let me create a variable, or probably we know, let's create another data set 1, which is a series from 1 to 100, right? I want to, and I have another data set 2, which is a series from 101 to 200. So I want to apply this function CV. So I'll put CV of DS1. I will find out the CV, which is the coefficient of variance. So it says it is 57.4485, which is nothing but it has found the standard deviation of that, divided by the mean, multiplied it by 100. Similarly, if I want CV of DS2, so it works like any other pre-built R function. So it says CV of DS2 is 19.27. So you could see that the coefficient of variance in the second one is much lesser compared to the coefficient of variance of the first one. So it is computing the standard deviation of the value that you have provided, divided it by the mean. So every time I don't need to do that entire formula. That entire formula I am giving it as one single function. So, and that function can be used like any other built-in function in R. So all I am giving it is the function name, right? I could give it as a function name also, right? And I have directly defined it as a function, but I can give some name to it, right? Probably I'll call it as CV here itself, right? I could typically call it CV as a function. You could see here CV, I have given it as a function name. Function, the inputs to this function is x. After that I have put an open bracket, and after that I have written expression. Expression is the set of operations that have to be performed by taking these inputs. So with the input as x, I am talking about a set of operations to be performed. So this set of operations can go for multiple lines, and all of them are enclosed in braces, open braces and closed braces. Whatever is the last thing that we are using in this function, so the last step is this one. that would be the typical return value. And whatever the x that we are using, now if I display x, it gives me some other value, right, which we have used much earlier. It has nothing to do with this x, because the scope of this x is only within this function. Once it is outside this function, that x has no meaning. And a few important conventions or practices, yes, again these are slightly advanced aspects. So just as a quick thing, I mean, my intention to provide here is we can write our own set of functions in case we are not able to trace some kind of built-in functions that are available in R. And it's just like you have to write that, you have to create that function once, and you assign it to a name. You can use that name from later onwards. That's a kind of an advantage we are talking of using the custom functions. So again, depending on the need, we'll start using the functions accordingly. And a few important good practices that I'm talking of: put the braces always after the function, even if it is a one line, just as a practice, just as a consistency. Once you have written function of x, start it with a brace, end it with a brace, anything in the middle is an expression. And all kinds of temporary values, create temporary variables to hold the results. Wherever possible, provide the comments using the hash function. Right? These are good practices, especially when you are writing very, very lengthy functions which become very difficult to be inspected at a later date. And what you want, put it as a return. So here I did not put any return, but I could have said return of this one. So return will directly tell me what has to be returned and displayed. So some of the common conventions that I suggest you should follow, though for very simple functions it looks like a very big overkill, but I'm talking from the perspective of if you start writing some lengthy functions, it becomes very, very handy. So this one, I don't want to spend too much time just discussing the structures, but just giving a kind of a feel. These are the different kinds of control structures that we have. If a test is true, perform this expression, else perform some other expression. So this is one more structure that I have. Based on the requirement, I can use this. Similarly, I have if else. So test yes, no. So if that is just like a if function of Excel. If the test is true, do the yes part. If it is not true, do the no part. Similarly, we have another structure, while test. So repeat this particular activity as long as the test is true. Only when this test value becomes false, then you stop this activity. So there is a while loop that is present, right? Depending on the need, as we move further, we will keep using them. But I see typically this one would be used more frequently, or probably this one, if else, and more, if at all something has to be used, we'll use the for. All others very rare to be used, but just people, if you have backgrounds in other programming languages, you might be aware of these kind of control structures. So just giving some kind of overview of these structures. Then again we have a for loop, name in vector. As long as this particular name is present in this particular vector, perform the expression, which means repeat it so many times. There is an iteration of this particular expression for each value of this name in the vector. Then I can have a switch function. So I am trying to match an argument name from the list. So this is the switch. I can repeat a particular expression until the break. So all these are the kind of control structures that are there, but very rarely being used for regular operations. So right now, until you get some hold on the usage of the regular aspects of R, you really don't need to get into these aspects. But yeah, when we take up any such kind of examples in our future sessions, I'll be definitely using them. But for someone who want to explore them, I'm just giving a list out here. And the if and for are very commonly used. And in some cases, the function that I am creating could very well be an anonymous function. I will not define a function separately like the way I have done earlier. When I am doing my other functions itself, let's say lapply or any such kind of a function when I am doing, within that itself I can create one of the functions. So the scope of it is only to that it is not saved as a separate variable. But again, if you think that you are going to use a particular function again and again, better name it with some variable so that you can access it at a later point in time. So let me tell you one final thing with respect to the R related computation. There are many ways to solve a problem, and the best way is the one that is making more and more sense to you, right? And finally, I've done so many things in R, now I want to quit. By default, everything is there in the memory. And when I'm saying quit R, I close the R window, or I use Q open bracket close bracket kind of a command, which means we are going to quit R. So let me try this. So quit. I get this kind of a message, save workspace image. So it always asks me whether I want to save so that I can load it next time. And if I really want to see what all are there in the memory, I can simply say ls. So these are all the different kinds of objects that I have created. A, ABC, array1, array2, B, CBA, CV, D, DF1. These are some of the things that I have created over a period. So these are all the things that are there as a part of my memory. Now, if I want to remove, right, I can simply say RM, let's say DS1. I want to remove DS1. Or if you look at LS now, I'll get it, DS1 will not be there, only the DS2 will be there now. And if I want to remove a list, right, I can even give it as a list. List equal to C of, let's say I'll put it as X, Y and Z. I want to remove these three. So I could put RM list equal to this. So now if you put LS, I'll not get my X, Y, Z, right? Now at the same time, I want to, let's say, remove this matrix, whichever are the ones that are having the name matrix. So this is where I can remove using list equal to ls of pattern equal to some string. So I'll say rm list equal to ls of pattern equal to the string that I am putting is matrix. So all the things that are, okay, I have to close the bracket. So all the things now that are having the word matrix in them, so if you see now ls, all those that have the word matrix in them, they are all removed. Right? Matrix underscore 1, matrix underscore 2, matrix underscore C, matrix underscore inverse, all those things are typically removed. So I can remove a list of objects, and probably if I'm saying list of ls and in that I don't put anything, then all the objects are removed. Rm list equal to ls this, all my objects are removed. Now let me see what is there in lx. I'll get character 0, which is that there is nothing that is present in it. So a cleanup is very much important before we are again loading some workspaces, because as we have already seen, when I am loading a workspace, the earlier values will replace the loaded or saved values will replace the existing ones. So it's better to plan it, clean it before we load something new. Before I quit, it's better that I take care of all these aspects so that I don't run into troubles with my execution process. So this is what I wanted to give you a picture of as a part of the initial understanding of R. So these are the various areas that we have looked at. In case you have further queries on the same, you can very well get in touch with me by giving me a call on the number that I have provided below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.